On August 17th, for the first time, scientists observed the collision of two neutron stars with both light telescopes and gravitational wave detectors. These observations led to confirmation of how precious metals like gold and platinum were formed. This week, we're going to talk about the technology that let this happen and what it means for us. Get ready, because this week's episode is going to be out of this world. I'm your host, Maddie Peterson, and you're watching Geographic. The recent collision of two neutron stars is really exciting for a lot of different reasons. But before we get to that, let's talk about some basics. A neutron star is the leftover core of a giant star after it has died from a supernova. The core collapses so quickly and becomes so dense that the protons and electrons fuse and become neutrons, hence the name neutron star. The neutron star was first theorized in the 1930s, but it wasn't until 1967, when we were able to detect the radio pulses that these stars emit, that we were able to observe them. However, the use of radio wave technology could only give us a small amount of information. And the recent collision of neutron stars, a crucial element in finding this phenomenon was the use of gravitational wave detection. Back in 1916, Albert Einstein predicted that the universe would experience gravitational waves, or ripples in the fabric of space and time. Many people have tried and failed to produce evidence of gravitational waves. That is, until research team LIGO finally figured it out. LIGO stands for Laser Interferometer Gravitational Wave Observatory. And this group, using observatories in Louisiana and Washington State, were able to detect the first gravitational wave back in 2015. This was an outstanding accomplishment, and the founders of LIGO just won the 2017 Nobel Prize for Physics. Now, with the European Observatory Virgo online, we can truly begin to detect these ripples in space-time. On August 17th, during a very boring meeting, a phone alarm went off in the pocket of the LIGO spokesperson. The observatories had detected something incredible, and just 2 seconds later, a NASA telescope detected a huge burst of gamma rays that could only come from an extremely large explosion. The LIGO team spoke with the Virgo team all the way in Italy, and together they were able to pinpoint the place in the sky where astronomers should point their telescopes. The explosion had taken place in the southern sky, so astronomers in Chile were the first to get a look. More than 70 astronomers were out that night, and in just 15 minutes, an email was sent between the observers with the exact galaxy the collision had occurred in. Just 11 hours after the gravitational wave detection, scientists were able to observe the collision firsthand. This whirlwind and flurry of activity is described by many of the scientists involved as one of the most surreal and exciting moments of their careers. Astronomer Edo Berger from the Harvard-Smithsonian Center for Astrophysics said that observing the collision was an incredibly amazing moment because it just stood out there. It was kind of like searching for treasure and then seeing X marks the spot. The debris of the neutron star collision produced almost 200 Earth masses of pure gold and 500 Earth masses of platinum, and the debate about how our precious metals formed is finally settled. This event was the first time we have ever been able to observe something with both light and gravitational technology, and it offers a whole new perspective to our understanding of the universe. The collision also provides a prime example of the power of remote communication and international collaboration. Without both of these things, we would not have the outstanding data we have today. Also, throughout this episode, you have been seeing artistic renderings and models of this event. So it wasn't only a win for the scientific community, but the artistic community as well. I hope you all enjoyed this week's episode, and see you next week, Seahawks.